12th standard physics. So lesson 3 magnetism. So in this class we are going to discuss about magnetic dipole moment of a revolving electron around the nucleus. So consider an atom. So electron revolving around the nucleus. So me is the mass of the electron. So r is the radius of an atom. So here, so what is the magnetic dipole moment? Mu L is equal to that is product of current and area of the loop. Here electron is revolving around the nucleus. So what is my current? Current is a flow of charge constitute the electric current. So that should be in a closed circuit. So charge is flowing in a closed circuit constitute electric current. So it is similar to the electron is revolving around the circular orbit. So around the nucleus. So it makes as a magnetic dipole moment. So that is mu L is equal to, there is a current, then area of the loop, that is mu L is equal to I times C. Then, so what is current? So I is equal to Q by T. So here Q is a charge, T is a time. Here instead of Q we are using, here is a electron is revolving around the circular orbit. So it's E. So what's the charge of electron? It's minus, then time period is capital T. So time period T. So what's my velocity? Velocity is equal to displacement by time. So we need time, so just rearrange. Time is equal to displacement by velocity. So what is the displacement? So to make one complete circular orbit, so what is the distance or displacement? It's 2 pi r. So r is the radius, that 2 pi is the circumference of the circle. So that is displacement. To make one circle is 2 pi r, then velocity. So time is equal to 2 pi r by v. Using equation 2 and 3, substitute in 1. So we need the magnetic dipole moment of a revolving electron around the nucleus. So mu L is equal to, it's minus I is equal to E by, that is minus E by T, then A. So A is the area of the circular, that is circular orbit, then just substitute T here. So T is equal to 2 pi r by V. So 2 pi r by V, then A. So area is a circular, that is area of the circle, that is pi r squared. Then pi cancel, so r squared, here r cancel. Then after correcting all those things, you will get minus EVR, that V is goes to numerator, so minus EVR by 2. Then, so what is the angular momentum of the electron? So the electron moving in a straight line, that is linear momentum. If it is moving in a circular, that is it makes an angle with respect to the velocity, that is angular momentum. So angular momentum of the electron L is equal to R cross B. So A cross B equal to AB sin theta. If angle theta is 90 degree, that means the radius R, then velocity, then angular momentum, all are mutually perpendicular to each other. Just see. So R is the radius, then V is the velocity, here velocity, then L is the angular momentum. If all are mutually perpendicular to each other, means angle is 90 degree. So A cross B equal to AB sin theta, sin 90 equal to 1. So the magnitude L is equal to RP. Then P is a linear momentum. So P is equal to product of mass and velocity. So finally we will get the angular momentum L is equal to R times, here R is the radius, then M is the mass of electron, V is the velocity of electron. So see here inside an atom, electron moving in a circular orbit with radius R. Here it's both are same. So we are making in the plane. So electron moving here in this direction. So what is the radius R, then velocity V, it moves. So what is the direction of dipole? That is dipole moment and angular momentum, both are opposite in direction. See, so what is the direction of that L? It's upward. That magnetic dipole moment, that mu L is in downward. So why? You will see. So mu L by L. So already we know that mu L equal to minus V EVR by 2, that is equation number 4. Then angular momentum, that is R times mv. Then mu L by L is equal to, so L is equal to, so it divided by, so it's 1 by RMV. So R cancel, VV cancel, finally we will get mu L by minus E by 2m. So the negative sign, so what it represents? So what is the direction of magnetic dipole moment? It's downward direction. Then what is the direction of that angular momentum of an electron in upward direction? So L and mu L are opposite in direction to represent that negative sign. So mu L by L is a magnetic, that is gyromagnetic ratio, it's a constant. So substitute the value of E. So E is a charge of electron, then M is the mass of electron. So charge of electron, it's 1.6 into 10 power minus 19 coulomb. then mass of electron, that is 9.1 into 10 power minus 31 kg. If you substitute these two values, you will get 8.78 into 10 power 10 coulomb kilogram power minus 1. So they may ask in 1 marks. So what's the value of gyromagnetic ratio? 8.78 into 10 power 10 coulomb kilogram power minus 1. So what's the charge? So what's the unit of gyromagnetic ratio here? Charge per mass, unit of charge is coulomb, unit of mass is kilogram. So coulomb kilogram power minus 1, they may ask in 1 marks like that only. Then according to Niels-Bohr quantization rule, so what's a Niels-Bohr quantization rule? That is angular momentum of the electron. So the electron moving in a circular orbit. So the angular momentum of the electron in a stationary orbit. So it's a fixed orbit. So you will study in the volume 2 lesson 8. So electron moving in a circular orbit, that orbit is stationary orbit. The angular momentum is quantized. It's fixed. So L is equal to n h cross. So h cross is equal to h by 2 pi. So h is equal to Planck's constant. That is 6.63 into 10 power minus 34 joule second. So n is the orbit. So if it is an electron moving in the first orbit, n is equal to 1. If it is second orbit, then it is equal to 2. So it goes on 1, 2, 3 up to infinity. So mu L, that is equal to E, mu L by L equal to E by 2m. So mu L is equal to E by 2m times L. So L is equal to n h by 2 pi. So substitute the values of h, then 2 pi, just rearrange all those things, you will get that magnetic dipole moment mu L is equal to n times E h by 4 pi m. So we know the values of charge of electron, mass of electron, Planck's constant. If substitute the values, you will get finally, substitute n is equal to 1, that is the minimum value. So the electron moving in the, that is circulating around the first orbit. So n is equal to 1, that is a minimum magnetic dipole moment, that is also called Bohr magneton. So Bohr magneton, so what's the value of Bohr magneton? 9.27 into 10 power minus 24 ampere meter second, or joule Tesla power minus 1. So both of the units they frequently using the 9.27 into 10 power minus 24 ampere meter square. So Bohr magneton, it's a minimum value of magnetic dipole moment, that is n is equal to 1. So it's a unit, it is used to measure the atomic dipole moment. So Bohr magneton is used to measure the atomic dipole moment. So they may ask whatever they like. So it's somewhat, so many 1 marks they may ask in 5 marks. So what is the magnetic dipole moment of a revolving electron around the nucleus? So what we have seen in this class? So first, magnetic dipole moment is a product of current and area of a circular loop. Then we are using a simple formulas we have studied in the lesson 2, some basics, then velocity formula, then finally that angular momentum of electron L is equal to r cross p. So r cross p, a cross b equal to ab sin theta. So the angle between r and p. So here what is the angle between r and p? This is a radius, then velocity. So what is the angle? It's 90 degree. Then compare this value. So angular momentum is in this direction. What is the angle between L and R? That is 90 degree. So a cross b equal to ab sin theta, sin 90 equal to 1. So L is equal to rp. So like that the derivation goes. So we will get finally the Bohr magneton and gyromagnetic ratio. So okay students, just go through the derivation. It's somewhat nice. It's some fundamental question. So we'll discuss next class a good question.